Hello, viewers. Welcome back. We're going to continue from where we stopped in our last class. In the last class, we discussed speed, velocity, how to use the formulas for speed and velocity to solve problems. Today, we are going to look at the equation of uniformly accelerated motion. So the three equations of motion with uniform accelerations are: equation 1 is v equal to u plus at. Equation 2 is equation 2 is s equal to ut plus half at squared, and equation 3 is v squared equal to u squared plus 2as, where u stands for initial velocity measured in meter per second, v stands for final velocity, t stands for time in seconds, and s stands for distance in a meter, and a stands for uniform acceleration or deceleration, and they are both measured in meter per second squared. So note that when an object moves or accelerates from rest, its initial velocity is equal to 0. So whenever you hear the word a body starts from rest, an object moves from rest, you should know that the initial velocity is equal to 0. Also, when a body comes to rest or stops, final velocity is equal to 0. And when a body's velocity is constant or not changing, then the acceleration there is equal to 0. So take note of these three points. When a body starts from rest, the initial velocity u is equal to 0. When a body comes to rest or stops, the final velocity is equal to 0. When you have a constant velocity, the acceleration is equal to 0. Now let's see how to solve problem using equations of motion. The first question says, a particle accelerates uniformly from rest. Take note, from rest at 6 meters per second squared. Since we are seeing second square, meter per second square, that shows that this is acceleration. Since it is from rest, it shows that u is equal to 0. For 8 seconds, that shows that this is time t. And then decelerate uniformly to rest. It comes to rest, and when it comes to rest, what happened? It shows that v is equal to 0. In the next 5 seconds, so we have another time here, the next 5 seconds, which is what? 5 seconds. So it's another time here, that is 5 seconds. Determine the magnitude of the deceleration. You should determine the magnitude of the deceleration. Are we clear now? So let's look at the first particle accelerate uniformly. So solution, we have this following data, that the initial velocity from the sentence is equal to 0. So at 6 meters per second squared, that's to show that A is equal to 6 meters per second squared. For 8 seconds, that is time t, is equal to 8 seconds. So if you look at it, from here, you see during this motion from rest and the time it takes t, we don't have the final velocity at this point. So final velocity is not known. So in that case, from here, we have to get our final velocity v, which we don't know. So we can use this formula v is equal to u plus at to find our final velocity, which is equal to the initial velocity here is 0 plus the final velocity plus the acceleration, which is 6 multiplied by the time taken, which is 8. So we have v is equal to 6 multiplied by 8. That will give us 48. So that will give us 48 meters per second squared. So now we have gotten to this point, and then decelerate uniformly to rest. So when it decelerates uniformly to rest in the next 5 seconds, so we have here the final velocity here will be equal to 0. Now, the initial velocity will be the final velocity of the first motion, right? So our initial velocity here is going to be 48 meter per second, right? And the time taken t here is equal to 5 seconds. So we're looking for deceleration. Deceleration is opposite of acceleration. So we're looking for deceleration. We can also use A for deceleration. The only difference is that deceleration is negative of what? Acceleration. So deceleration is equal to, we have final velocity V minus initial velocity U all over T. So this implies I have deceleration A is equal to final velocity is 0 minus initial velocity here is 48, then all over time, which is 5. So this one will give us minus 48 all over 5. So what is minus 8? 48 over 5 is equal to 9.6 meter per second squared. Remember, it has negative. So this negative shows you that it is a deceleration. So deceleration A is equal to minus 9.6 meter per second squared. So now, look, if we use a velocity time graph to do this, you will see what I'm talking about. So let's try that and see. So here is time in second, and here is V in meter per second, right? So a body accelerates uniformly, from rest, show that U is 0 here. The initial velocity is 0. Now, at 6 meter per second, that is the value of acceleration, which is 6 meter per second squared for 8 seconds. So trace it down to the time axis. So that is 8 seconds. Now, remember here, we were not told the final velocity, so we don't know it. So that is why it is V here. The initial velocity is 0 because it starts from rest, but the final velocity is not known, so put V. Then decelerate, that is, it goes down, right? It goes down to rest. This is deceleration, right? This is deceleration, which is, we don't know the amount of deceleration. We are not told. In the next 5 seconds, right? So the time taken here, 8 plus 5, that will give us 13 in the next 5 seconds. So determine the magnitude of the acceleration. So that is what we did here. The first magnitude of deceleration. So the first thing you do here is to use this value here. You have U, you have A, you have T, you have what? You don't have V. So we use this value we have here to get V, which gives us 48 meter per second here. Sorry, 48 meter per second. So from there, whatever you have here, when it's decelerating here become our initial velocity, and here become our final velocity. So our initial velocity here, as the body is decelerating, becomes what? 48 meter per second. And the time taken is differences of 13 and 8, which will give us 5. So we have our time, we have our initial velocity, which is this, and we have final velocity, which is 0. Then we can get our deceleration. That is how we come about this. I hope this is understood. So that's how you solve this type of question. So let's look at number 2. A body accelerates uniformly from rest. So as you hear, from rest, just indicate that your U is equal to 0 at the rate of 3 meter per second squared. So if you see 3 meter per second squared, meter per second squared, it shows that this is a acceleration. For 8 seconds, show that this is time taking. Calculate the distance covered by the body during acceleration. So I'm looking for distance covered. So solution. So the data we have are, we have U is equal to 0, A is equal to 3 meter per second squared, and time T is equal to 8 seconds, and we're looking for distance S. So we have this. Which of the 3 equations of motion that is appropriate to solve this problem? Let's see. We have V equal to U plus AT. We have S is equal to UT plus half AT squared. and we have v squared is equal to u squared plus 2as. So which of these three equations is appropriate to solve this? Looking at the first equation, we have u. Yes, we have u. We have a. We have a here. We have t. We have t. We are looking for s, but there's no s. So this equation is out of point. The next is s. We have it. We are looking for it. U, we have it there. T, we have it. A, we have it. So this is very appropriate for solving it. If you look at equation 3, we don't have V, the final velocity in these parameters. So therefore, it is not appropriate for the question. So the only one that is suitable for this is a second equation, S is equal to UT plus half AT squared. So you now put down your equation, which is S is equal to UT plus half AT squared. Sorry, AT squared. So this will be equal to U is 0. So whatever you multiply by this is going to give you 0. So don't waste time, especially if it's subjective, don't waste time. So we're going to have if half AT squared. So this will be equal to 1 over 2 multiplied by A is 3 multiplied by T is 8, then squared. So we're going to have it to be 3 multiplied by 64 all over 2, which will give us 3 multiplied by 32, right? Because 2 here 1, 2 here 32. That will give us 96. That will give us 96 meter. I hope this is understood. The next question says, starting from rest, a Formula 1 car accelerates uniformly at 25 meters per second square. Starting from rest, I want to remind you, since the object starts from rest, u is equal to 0. So starting from rest, a Formula 1 car accelerates uniformly at 25 meters per second square. So this is A. For 30 seconds, this is what? T. What distance does it cover in the last 1 second of the motion and the distance it covered in the 17th second of the motion? So let's solve this again. So u is equal to 0 and the acceleration A is 25 meters per second squared and time t is equal to 30 seconds. What does it cover in the last 1 second? So here the total time is equal to 30 seconds. The last 1 second, right? The last 1 second is the differences between the 30th second and 29th second. The last 1 second is the differences between the 30th second and 21st second. That is, you're looking for the last 1 second is equal to T 30 times 30 second minus what? T 29. So this is the last 1 second of the motion. So in that case now, looking at this again, which equation of the three equations that is appropriate for this solution? You have U, you have A, you have T. Then you're looking for distance, S. So that's what we're looking for. We're looking for S. So we can use S is equal to UT plus half AT squared. So as I said, the last 1 second of the motion is the time at 30 seconds minus time at 29 seconds. So we're looking for distance in the last 1 second. Distance in the last 1 second, let it be S, is equal to distance in 30th second, right? Minus distance in 29th second. So that will give us the distance in the last 1 second. So if gotten this, so remember our formula, S equal to UT plus half AT squared. So I'm going to write it for time T second and time 29 second. So for time T second, I'm going to have U multiplied by T 30th minus half, right? AT 30th all squared. Is that clear? Again, plus this from this formula is plus. So we have plus, then minus for the 29th second, I'm going to have U multiplied by T 29 seconds plus half AT 29 seconds all squared. Is that clear? So remember that since it is initial, it starts from rest, U is equal to 0. Automatically, all these things will become what? 0. This one will also become what? 0. So S will be equal to half AT 30th squared minus half AT 29th squared. So what is common? A is common. A and half is common. So S will be equal to half A into bracket T 30 squared minus T 29 squared. So this is the formula we derived from this. We are going to use it for this question. So anytime you have this type of question, you can actually get it from this idea. So now, since we have gotten that, we can now get our substitute value for all this and get it direct. So S will now be equal to 1 over 2 multiplied by A. What is A? 25. 25 multiplied by time 30, 30 squared minus 29 what? 29 squared. So this will be equal to 1 all over 2 multiplied by 25, multiplied by 25 into bracket 30 squared. That will give us 900. 900 minus 29 squared. 29 squared. That gives us 841. 841 all squared. So I can have it to be equal to 1 over 2 multiplied by 25 multiplied by 900 minus 841 gives us 59. It was 59. So I'm going to have 25 multiplied by 59, everything divided by 2. Everything divided by 2. So that will give us 1475 all over 2, which will give us final answer to be 737.5 meter. 737.5 meter. So this is how to come about this type of question. I hope this is understood. So now I believe you should be able to solve the second one, the 17th second of the motion. So the 17th second of the motion is going to be the distance at the time T17 and T16. T17 and T16. So using the formula, we are going to have it to be the distance in the last 17 seconds will be equal to S17 minus S16. So from the formula that we just got, S will be equal to half A into bracket T17 squared minus T16 squared. Is that correct? So that will be equal to 1 over 2 multiplied by 25 into 17 squared minus 16 squared. So quickly, we have 1 over 2 multiplied by 25, then multiplied by 17 squared gives us 289 minus 16 squared give us 256. 256. So I have it to be 1 over 2 multiplied by 25 multiplied by 3 multiplied by 33. This implies we have 25 multiplied by 33 all over 2, which will be equal to 825 all over 2, which is equal to 412.5 meter. 412.5 meter. I hope this is understood. So that is it for this type of question. The next question says, a body uniformly accelerated from rest. Again, u is equal to 0 at 8 meters per second squared. In how much time will the body travels a distance of 2.5 kilometers? So let's itemize what we have. So given that the initial velocity is equal to 0 since the body starts from rest, then the acceleration is equal to 8 meters per second squared. In how much time we're looking for t, and the distance is given to be s equal to 2.5 kilometers. Except otherwise stated, always convert from whatever unit to meter. So we have 2.5 kilometer converted to meter. That will be 2.5 multiplied by 1,000. That will give us 2,500 meter. Are we together? So having done this, from our three equations, which do you think is appropriate for this? The same thing S will be appropriate. We have S is equal to UT plus half AT squared. Here our S is 2,500 is equal to, since U is 0, it means everything here is going to be 0. Take note of that. So automatically we're going to have it to be 1 over 2 multiplied by the acceleration, which is what? 8 multiplied by t squared that we are looking for. So from here, I have 2,500 is equal to 8 multiplied by t squared all over 2. So I can say 2 here, 1, 2 here, 4, which implies I have 4t squared equal to 2,500. So divide both sides by 4. Divide both sides by 4. So t squared will be equal to, what is 2,500 by 4? That will give us 625. So t now, sorry. So t will be equal to root of 625. So therefore, t is equal to, when you find the square root of this, that will give us 25 seconds. That will give us 25 seconds. So the time taken to travel a distance of 2.5 kilometers is 25 seconds. I hope this is taken. So the next question says, a particle starts from rest and moves with a uniform acceleration. A particle starts from rest. So solution, it starts from rest, u is equal to 0, and move with uniform acceleration of what? A is 4 meters per second squared. What is its velocity after? Velocity after means final velocity. Final velocity, v. So we are looking for final velocity v. We don't know it. After covering a distance of what? 8 meters. So s is equal to 8 meters. So which formula is appropriate here? Are we going to use s is equal to ut plus half at squared? Here we don't have what? Time, so we cannot use it. So I think the appropriate formula here is going to be v squared equal to u squared plus 2as. So in that case, we have v, we have u, we have a, we have s. So in that case, v squared, which you are looking for, is equal to u squared is 0, that's 0 squared, plus 2 multiplied by the acceleration a, which is 4, multiplied by the distance covered, which is 8. So in that case, we have v squared is equal to 2 multiplied by 4 multiplied by 8. So v squared is equal to 64. That implies that v is equal to square root of 64, which will give us v to be equal to 8 meters per second. 8 meters per second. I hope this is understood. So these are some of the way we can apply the equations of motion to solve problems. I hope this is taken. So this is practice questions for you. A motorist travel at 120 kilometers per hour sees a broken down truck and the middle of the road and immediately applies his brake and come to rest or come to a stop with uniform retardation in 20 seconds. What distance does the car travel after the brake were applied? Right? And the next question says, a body which is uniformly retarded comes to rest in 5 seconds after traveling distance of 10 meters. What is its initial velocity? So I think just pause the video and try this question and see if you can handle them. So try it, whatever may be your answer, come back and see the solution to the practice question. Now let's do this, the practice question. I hope you have tried it and I believe you have gotten the answer, the right answer. But see how I'm going to do my own here. So solution. So according to the question, it travels traveling at 120 kilometer at this speed, which is the velocity. So here, the initial velocity here is 120 kilometer per hour. There's nothing like it come to rest at this point. It's traveling at 120 kilometer per hour. Traveling at 120 kilometer per hour. That case, the initial velocity, u, is equal to 120 kilometer 120 kilometer per hour, 120 kilometer per hour. So when you have this, the first thing you do is to convert to meter per second. So that will be equal to 120 multiplied by kilometer. To convert kilometer to meter is by 1,000. Then per, that is over. Hour, to convert hour to second is 3,600. So 3,600. So we're going to have it to be 120 multiplied by this 120 multiplied by 1,000 gives us 120,000. Everything divided by 360, 3,600. So when you do that, so you have your initial velocity to be 3.33.3 meter per second. That's the first step. Sees a broken down truck at the middle of the road and immediately applies his brakes and comes to rest. They say it comes to rest. So if an object comes to rest, what happened? The final velocity is equal to 0. So have final velocity is equal to 0. It comes to rest, right? It comes to rest. That is, come to a stop with uniform retardation in 20 seconds with uniform retardation. So in this case, we are not giving that retardation here, which is opposite of acceleration. So it comes to rest with uniform retardation. We don't know the magnitude of that retardation. So we don't know it. So in that case, we should know that we don't know the magnitude of the retardation here, right? Retardation. We don't know it. Remember, I told you it's opposite of what? Acceleration. So in 20 seconds, so we have time t is 20 seconds, right? So the question now say, what distance does the car travel after the brakes were applied? We're looking for distance s. So we don't know the distance. So we are looking for two things at the same time. So, but we can find it. It's very simple. Remember that this relation A is equal to final velocity minus initial velocity as well, all over time. So here we have final velocity, we have initial velocity, and we have time. So we can get our deceleration here first before we go for the distance travel. So this will be final velocity is 0 minus initial velocity, which is 33.3 all over time taken, which is 20. So we're going to have it to be 33.3 divided by 20 will give us 1.67. So that will be negative. So because it's a deceleration, we're having minus 1.67 meter per second squared. So when you got this, come back now. In your formula, remember we have U, we have V, we have A, we have S, we have A, we have S. So which of these formula do you think is appropriate? Is it S is equal to UT plus half AT squared, or we use V squared is equal to U squared plus 2AS? So in my opinion, any of these we use, we are going to get S. S is here, S is here. So we can use any of the equation. Let us use this last one. V squared is going to be 0, right? 0 squared uh, equal to U squared initial velocity, which is 33.3 all squared, plus 2 multiplied by this A in this time around is deceleration, which is minus 1.67. Then multiply by what? The S that we are looking for. So this will be equal to 0 equal to 33.3 squared gives us 1108.89. Then remember this is 2 multiplied by minus. So I'm going to have minus 2 multiplied by 1.6, 1.67. That will give us minus 3.34, right? Then S. So this one will cross this equality sign. I'm going to have minus 1108 sorry, 8.89, right, is equal to minus 3.34 S that we are looking for. So minus, we cancel minus, then divide both sides by 3.34. 3.34 all over 3.34. So S will be equal to, S will be equal to 1108.89, everything divided by 3.34, which will give us 332 meter. 332 meter. You can as well use the second formula to test what if we get the same answer. You can use the second formula. S is equal to UT plus half AT squared. So this will be equal to our initial velocity is 33.3 multiplied by time, which is 20 plus half multiplied by A, which is minus 1.67, then all multiplied by time, which is what? 20, then all squared. So this will be equal to 33.3 times 20 gives us 660 plus this is numerator. We can say 20 square gives us 400. Then 20 square gives us 400. It's like 400 multiplied by minus 1.67, everything divided by 2. So I can as well say 666, right? Plus, what is 400 multiplied by 1.67? It gives us minus 668 all over 2. All over 2. Then this is going to be 666, right? Since this plus times minus is minus, then 6 is 8 divided by 2 gives us 3, 3, 4. 3, 3, 4. Sorry, this is 4. So we're going to end up having 6, 6, 6 minus 3, 3, 4. That will give us 3, 3, 2, which is the same answer, 3, 3, 2 meter. So any of the formula you use, you're going to have the same answer, 332 meter. I hope this is understood. Now, the second question says, a body which is uniformly retarded comes to rest in 5 seconds after traveling a distance of 10 meters. What is the initial velocity? Right? Okay. Here, I think, okay, let's see what we have again. Said retard, uniformly retarded. So we don't know the magnitude of retardation. Let us call it A. Comes to rest, it shows that V is equal to 0 in 5 seconds. That is our T. After a total traveling a distance of what? 10 meters. That is our S. We are looking for what? U. So in the first instance, let's use this to calculate U, right? Let's use this parameter for that retardation. Let's use this parameter to get our U. So we have A, that is question 2. We have A, the retardation. We don't know its magnitude. And we are looking for the initial velocity. So 2 parameters, and V is equal to 0, yt is equal to 5 seconds. So remember that A is equal to final velocity minus initial velocity all over what? All over t, right? So in any instance, let's check our acceleration, deceleration this time around, that's retardation. So A is equal to 0 minus U, we don't still know it, all over T, which is 5. So it shows that deceleration is equal to minus U all over 5 meter per second squared. This is our deceleration. So, and they told us that it traveled a distance of what? 10 meter per, 10 meter, sorry, a distance of 10 meter. So which formula is appropriate for this? Is it v square is equal to h square plus 2as, or which formula? Right? So I think any of the formula that contain s will work for us. Let's try v squared. V squared is equal to u squared plus 2as. So v squared is 0, the final velocity is 0, minus u, which is u squared, is equal to u squared plus 2 into bracket. This time around, A is minus U over 5, all multiplied by what? Multiplied by T, which is 10, right? No, it's 10. Is it 10? Multiplied by S, the distance, which is 10. Is that clear? Then we have 0 is equal to U squared plus all this multiply. They're going to be minus U minus 2U over 5, then all multiplied by 10. So I can as well say 5 here, 1, 5 here, 2. So which you end up having 0 equal to u squared. Then since minus is here, 2u times 2, that will give us what? 4u. So minus 4u. Is that clear? So now, what is common? That is, I'm having u squared minus 4u equal to 0. What is common? I have u is common. If I bring u outside, I have u minus 4 equal to 0. This implies that u is equal to 0, or u minus 4 is equal to 0, which implies that u is equal to 4 meter per second. So the final velocity, initial velocity is 4 meter per second. I hope this is understood. So we use the first instance to get A in terms of U. Then any of this equation that contain S will work for us. Let's try again. If you use S is equal to UT plus half AT square, it will still work for us. So here, S is 10 equal to U multiplied by T, which is 5, then multiply by 1 all over 2 into bracket A is minus U over 5, then multiply by 5 squared, that is T squared. So this is 10 equal to 5U, 5U. Let's open the bracket. This is a numerator, this is denominator. I'm going to have like, let's say plus, open bracket. 5 squared is 25. That will be minus 25U all over 5, isn't it? Multiplied by 1 all over 2. That is half. So that will give us 10 is equal to 5U. Then this will give us 5 here, 1, 5 here, 5. So this will be plus minus 5U, minus 5U into 1 over 2. 1 over 2, right? So I can as well say that this is the same thing as 10. 10 is equal to 5U, sorry, please, 5U plus into minus 5U all over 2, just to simplify it. All this, it doesn't need all this longer thing. So if I say here now, I can say that, okay, 10 is equal to 5U minus 5U all over 2, right? So what is the LCM here? I have here to be 2, 2 in 1 in 2, that is 2, 2 times this give us 10U, sorry, 10U minus 2 into 1, this will give us what? 5U, right? So this will be 10 is equal to 5U minus 10U minus 5U give us what? 5U all over what? All over 2. So when I cross multiply, I have 5U will be equal to what? 2 times 10 gives us what? 20. So for us to get U, divide both sides by 5. Divide both sides by 5. 5 we cancel 5. This implies U is equal to 20 divided by 5 give us what? 4 meter per second, just like the first one. I hope this is understood. So this is how to come about it. If you solve it yourself and you couldn't get the answer, just come over and see the solution to the practice question. Thank you for watching. We'll stop here for today and continue from this in our next class.